Hi, Ed Kovitl here, and this is the first episode in a new series I'm going to call Clojure Essentials or something like that, where I introduce you to libraries that I think are essential to, at least, well, essential for doing certain things in Clojure that I want to do. Maybe not so much writing Clojure in general, but yeah. And in today's episode, I want to show you the RM Hall Infix library. It's a not very well known library, I guess, but I think it is great. And what it lets you do is write infix notation, and this is extremely useful when you're doing anything that involves math. And I've been doing a lot of math, and it has been a headache because you have to translate. So the thing is, you read math like in a book, and then you want to use it in Clojure, and what you have to do is you have to translate it into the Clojure notation, which I guess is called prefix, and uh, and math is the infix notation, where the operators are in between the operands, and yeah, it's just a headache. There was one function in particular, so it took me only a couple of minutes to write it in Python, and that includes googling for like how to do a for loop in Python because yeah, I'm not using it regularly, so I forget how stuff works. And but yeah, it was pretty easy, and doing the same thing in Clojure took me well like an hour. And I mean, to be fair, it was in the evening. I was tired, but it took me forever. I couldn't even finish it on time. So I had to. There was a bug. I didn't know what it was. I couldn't see it because I was too confused with all the prefix notation going on. And in the end, I was only able to finish it the next day. And then I figured out, oh, there's this thing called Infix, this library called Infix, this macro called Infix, and it lets me basically take the Python code one to one and translate it to Clojure uh, without too much trouble, with some trouble, but not too much. And I'm going to show you like this right now. So here we have we start with the simpler of the two functions. So here we go, and I just copy it over. In here. Well, comment it out. So I guess before we start, so I'm referring to the infix macro, and I'm renaming it to like the law sign because I'm using it like extensively, and I don't want to like spend too much time. There is, by the way, there's similar macro in the incanter library. However, there is a difference in that functions within the infix notation are still like in the Clojure notation. So if you want to do something like that, it doesn't work. And especially like if you have infix within the application, and like the infix macro from RM Hull, it lets you do that. So to me, that's preferable. But you can do it with the other one as well. But you have to like apply functions like that and then use the macro again. Okay, so we have our function definition here, and we want to well, that stuff is straightforward. And so yeah, let's start here. We have an R. Well, actually, here we don't translate it literally. What we want to do is, well, I'm just copying it from somewhere else because it doesn't have anything to do with like math, or almost nothing. So yeah, there's also like a sum over thing that I've defined. However, where we can use it is basically here. So this basically does the same as this. So it creates an R that is, yeah, well, I mean, I know that it's the same because I'm very familiar with the math involved here. You just have to trust me on this one. I mean, it gets more interesting, like when we start computing like this variable here, and yeah, all you have to do. By the way, I'm using like the US International keyboard, so for me this is like easily reachable. I'm not sure about the US keyboard, but yeah, this is like a very handy and I was always surprised that nothing else is like used for it, but I guess that's because it's not that easy to write in the US keyword. But yeah, so here what we want to do is we have basically this formula, and we want to use it in Clojure, and we can pretty much copy it, and really the only thing we have to change is we have to use Clojure spacing. So for Clojure, those things would be, that would be one symbol, but you want to make sure that the macro can use symbols. And this is, in Clojure we can't do it like this. However, since vectors are functions and function application works like this, in the infix notation we can do it like that, and we have the index I of the q vector. So that's pretty great. Again, the power law thing has to have spaces, and we can do this here again, and yeah, that has to end here. So yeah, that's basically it. What we want to do maybe is put it in the new line, so it's this term over this term, and it was almost a one-to-one translation of the thing from Python, which I think is great. So the next thing we have is like an if statement, and well, that was too much. And again, we can, I mean, it doesn't make too much sense here, but again, we can use the infix notation here, and then we can write it like this, which is, I mean, at this point it almost gets scary because you're not writing like Clojure anymore. This is yeah, this is totally different. But I think it makes sense to use it here because this is like a purely mathematical if statement. I wouldn't recommend it like using it in general for if statements, but in this case it's it makes a lot of sense. So yeah, I don't have the algorithm like in math notation open, but yeah, but you can see it is like just math. And yeah, we want to return this thing, so we just do it like this. Well, we should. And again, well, this is almost like working. All you have to do is this. Wow. And same thing goes for this. There we go. And all we have to do is add the spacing, and we have it working, which is great. Well, actually, let's yeah, the sum over isn't defined, so I can show you what it does. It's really just it maps a function, then reduces the plus, which I guess is similar to this thing. So too many arguments to if, that's not true. Well, I got a little bit too comfortable. That's actually the thing. You start to mess up like the infix notation and the postfix notation. I got I got too comfortable here with the. So okay, and here we have. Yeah, I don't want to go into the details of what this is. Maybe I do a video about that kind of stuff I'm working on as well, but I guess it's of limited interest. Oh, yeah. So yeah, it's totally working, which is great, I guess. Although I'm not sure if that is correct. Well, that's a different question. Okay, maybe we do another one, just for the fun of it. The more complicated one, this is the one where I actually struggled with. Let's jump over here. IQBVP, and actually we can go fancy here and make it like this. I think it's like this. This is like test the same, and I mean, why not do it like this? This should be the same. Let's test it out really quick. So we have vector like this, make it like this, and there we go. It works. So we have translated this. So the next thing we have, again, those terms, but I don't want to. And in fact, let's copy this one too, because we already did it. So, and we also include the if statement. And this is where it starts to get different. Well, actually, yeah, this is, by the way, I don't know what the best way to basically do this is. So what those things are supposed to do down here depends on this condition. I mean, one thing that I found that works decently, but maybe there's better ways to do it, is basically this. So the structuring for a map here, and then I'm doing like the condition, well, yeah, like this, and here I'm building a map that has those keys, and then later it will be destructured and like be assigned. And here's the second map for the and the trackpad is that palm detection isn't working perfectly. Alright, basically do it like this. I hope you can see what's going on here. This is like advanced Clojure. Well, no, it isn't. So this is the same formula, so I'm just going to copy it. I mean, I could also, this is another thing, by the way, where I'm not sure what like the Clojure way to do it is. So basically I could just call this function here, obviously, but what I'm doing here is like I'm having like this if I would it would like check the if inside the function, and then it would check it here again, which really doesn't matter like from a computation standpoint, but it kind of matters from a maybe maintainability standpoint, and definitely matters from like standard of elegance. So instead I opted for copying the stuff here, which is bad as well. So yeah, I don't know, should cut this part out, I guess. But what we want to do now is take the function and actually both of them and make them, well, actually let's do it like this and make them Clojure-ish. So we go here. By the way, the nice thing about Clojure that you can actually name them like this. And yeah, this is an anonymous function, so I guess what we do is like we have a function like that, and we have a function like that. Alright, and again we use our macro, and we make sure the spacing trackpad, we make sure the spacing is correct, and we have some different ones, and there is another one, and maybe we should make this, split this up into multiple lines. Yeah, that works. And in fact, this one goes here. So, and this is like the only part where it gets tricky, because this is not possible. But since we know that minus is a function in Clojure, we can call it like that. But now it is confused with the operator precedence, I guess, and you have to do this as well. So this is, I mean, probably you should, I mean, you could state the same thing with 1 over the expression, but let's stick with the literal translation here. So we have, hey, there's something seems not right. Oh no, it's okay. So we have it this and this, and this basically is the entire algorithm, and it fits on the screen. So, and we do the same thing here. That's it for this part. So actually, you know, I guess we're getting the idea here. So I'm just copy the second part over here. By the way, this is how it looked in Clojure. So writing that wasn't fun. And we have the second functions. There we go. Yeah, those are like literals. Yeah, doesn't matter. And now here is where it actually gets. I think that part is pretty fun. So, and where the macro shines. So we just have to make sure that we are the right indentation. I don't know. And I guess we have our x here. Again, we use the macro. We want to do q of I plus dqi over b, and this needs to be, oh, actually it is. So yeah, well, no, it doesn't. Needs to be in parentheses. There we go. And then we have a while statement. And oh yeah, what follows here, and this is, I think, where the macro is really great, is you want the absolute of f of x, and we want that to be, so well, this is bigger than the second expression. I'm not sure if this is how while works in, by the way. Yeah, actually, let me rewrite that. You want to use a loop here, and because x, I guess you could make it work with while as well, but so yeah, here we have an if instead. So if the condition is met, we keep iterating. So this is basically like a custom implementation of Newton's method. In case you are familiar, so in that case we recur with a different x, and again we can use the macro, and this is just Newton's method straight out of the math book, basically. Here we go. And otherwise we have a solution that's close enough, and we return it. And well, actually, you know, now this part, you want to write this part. Let's just do it like this, and we have b times x minus q of a, and that's our solution. This is supposed to work. Okay, unable to resolve q in this context. That is not true. That is totally true. How to, well, interesting. Must have messed up earlier. Okay, and we can, and it works, and it's the right solution, which I happen to know. But yeah, this is the Infix macro. It is absolutely amazing. If you ever done anything with math in Clojure and you didn't know that this macro existed, you know the pain. I know the pain of writing this stuff, and I almost gave up on Clojure. It was that bad, so I wrote it in Python instead. And thanks to the macro, I'm back again. I don't know, maybe not enough people are doing math stuff in Clojure, and well, arguably it's not the best platform, but if they were, this thing would have way more stars because I don't know, it's just absolutely amazing. I think it just makes math in Clojure so much fun, so great with all the other amazing Clojure stuff. So yeah, this is the first entry in the Clojure Essentials series, and I hope I will ever record a second one of those. I shouldn't call those a series until there's at least 2 or 3 in them. But yeah, thanks for watching and see you next time.